I ain't talking about that.
Oh, you just talking to yourself today? All right. So percent of change. Okay. This is the percentage of the distance between an old price and a new price. So we will have an increase in percent of change or a decrease. So the way we find percent of change, you take your new value, how much you would pay now, divided by your old value, how much you would have paid, and you subtract 1. Okay, so if you look, number 1 is done for you. So your new value was at 28, your original value was at 25. So you can clearly see from there that that should be increased. When you divide the 2 and subtract 1, you get 1 or 0.12, which means that is a 12% increase. Remember, to go from a decimal to a percentage, we move your decimal places 2 spots to the right. So if you look at number 2, your original value is a 30. Your new value is a 12. Should this be increase or decrease with your percent of change?
Decrease.
What?
Decrease.
Decrease. You would have originally paid $30. You're now only paying 12. So it's decreased. It's gone down. So you take your new value, 12. We divide it by your old value, which is 30, and we subtract off 1. Negative 0.6. So this negative tells you that this is a decrease. 0.6 written as a percentage, you move that decimal 1, 2 spaces to the right. When you have an opening, you fill it in with a 0. So this is a 60% decrease. The price has gone down by 60%. Okay, number 3, your new was an 18, your original was a 25. Is this increase or decrease?
Decrease.
This is also a decrease. Again, new divided by old minus 1 gives me negative 0.28. So this is a decrease by 28, bless you, percent. My original is 13.7. My new value is 40.2. Increase or decrease? Increase. Okay. My new value is 40.2. My original is 13.7. Again, minus 1. 1.93. So because it's a positive, that automatically tells you increase by 193%. It's almost doubled the original value. Okay, don't get confused with 5 and 6 because they've changed your words now. We're looking at initial and final. Okay, your initial is your original, your final is your new. So, should this be an increase or a decrease? This is a decrease. So, 94.86 divided by 102 minus 1.
Negative 0.07.
Good. Negative 0.07. So again, that negative tells you decrease. And this time, it decreased by 7%. It's a small gap in the numbers. The last one, start is 215, end is 464.4. Good. And end is your new.
Right.
So, have we increased or decreased? Increased. So 464.4 divided by 215 minus 1. So it's positive, so that tells me increase.
116%.
And 116%.
It's going to be hard.
Does everything always get harder?
Yes.
Although I will tell you this, when we get to geometric sequences, it's a lot easier than arithmetic ever will be. Questions on percent of change for this section? Okay, so percent increase is always more than 100%. So if we're increasing, we take whatever percentage we're doing and we add it to 100. Decreasing is always less than 100%. So you would take 100 minus what you're taking off. So if you take a look at number 7, actually, take a look at this first. So we would multiply the starting value times the decimal that you would get to get your ending value. If for some reason they give you your ending value, you would divide by the decimal to get your starting value. So it's backwards. Okay, think about that. So if you take a look at number 7, it says we're depreciating by 12%. Depreciating means what? Decrease. So you would take 100 and you would subtract off the percentage that you're decreasing by. So if we're decreasing by 12%, that means we're technically only paying 88% of the value. Make sense? Okay, so we then convert it. 88% as a decimal is 0.88. They gave us an initial value of 800, so you multiply that by the percentage. So with that decrease, you would only pay $704. Yes.
With that start value and end value, that's still original and new, based off of that.
Yes, your starting value would be your original, and your ending value would be unique. Absolutely. Number 8, we've got concert tickets. They cost $45. The sales tax is 6.25%. What is the total price of the ticket? If we're putting it with sales tax, what's happening to the price? Increasing. It's going up. So you would start with 100, and you would add on what it's increasing by, 6.25. That gives me 106.25. Okay.
So how will you use the decimal for?
We're getting there. I promise. People struggle with the fact of it increasing versus decreasing. So I tried to simplify it with adding to 100, subtracting, and then we change it to a decimal. Okay. So we're increasing. You add it to 100. Now let's change this to a decimal. So what do I do to go from a percentage to a decimal?
Move to decimal.
Which way? To the left. 2 spots. 1, 2. So this is 1.0625. Okay. They gave us the original price. We need to get the new. So we multiply. So my tickets were $45. We multiply that by what it's increasing by, and this will give you your new ticket price. How much are we paying for the concert tickets?
$47.81.
$47.81. Somebody last period said to me, why don't you just take the original value, multiply it by the decimal, and then add the 2 numbers together? You can do that too.
Wait, what did they say?
Okay? So you could have done this by, you would take 45 and you would multiply that by the decimal part of this. Okay? That's the decimal version of 6.25%. And you would get an answer, which comes out to be $2.81.
Oh, yes, sir.
And then you would add that to 45. And that gives you 47.81. That works too.
You do that method on the test when it's still.
I don't care.
All right.
You do whatever works better for you. I don't care. My goal is the end. Okay? I don't care what means you take to get there, except cheating. Don't do that.
Okay, $7.
Okay. So a sweater is on sale for 35% off the original price. So if it's on sale, are we increasing or decreasing? Decreasing. So this time, we subtract from 100. That gives you 65, written as a decimal, 0.65. Okay? My original price is 38, so that means we multiply. So how much money do I pay for a sweater? $24.70. Again, you could have done it this old-fashioned way, where you would have taken 38 times 0.35, and you would get the amount that you would take off of it, and then you would subtract that from 38 to get $24.70. Oh my God. Okay, number 10. We've got 3,000 students and they're being decreased by 20% because we've created a new high school. So 20% of the population is going to that new high school. How many students will now be at the original school? So I'm decreasing. So what am I doing with 100?
Subtracting it.
Subtracting it. So 80% of the students are staying.
0.80.
0.80. They gave me the original, so we multiply by 3,000.
So 0.80.
Good. There's 2,400 students left in the building.
Only a small chunk out of it.
Right.
So that new school like real small or something?
I don't know. It could be students coming from this school and this school and this school to build a school,
True.
like they did with Oak Grove.
That school is nice.
A company predicts 15% increase in production. 15% increase. We do what? Add. So technically you're paying 115%. Written as a decimal is
1.15.
good. Okay, so we started with 405,500 units. How many will there produce now? So they give us the original, so we multiply. 466,325. We're almost done with percent of change, and then we get to talk about exponential growth.
Yeah. Not hungry. I want a cake.
Did you just say you're about hungry? You want cake?
I want some cake.
Well, it is Lewis. Okay. A new car was marked up by 20%, which means it has been increased. So we add it, which gives me 120, written as a decimal is 1.20. Okay, now read the rest of it carefully. The car company is currently selling it for $50,000. What was the approximate original price for the car?
So we're going down.
We need to divide this time. We're going backwards. They give us the price we're paying now. They want to know what the original price was. So you would take 50,000 and divide it by 1.20 instead of multiplying. $666.67. Why would they mark up the price for the car?
Because
Because of value.
yeah.
That never happens.
Car's value will never go up.
But I don't even
Oh,
want to
yeah.
raise 66.
Because
I don't know,
Yeah,
maybe there's multiple offers on it, maybe because Barack Obama signed
What's
it.
this, an antique?
Okay.
Maybe they stopped
Was
consumption.
it bulletproof?
Think about it. So, a car company, a company has to buy the cars in order to sell them. So they buy them at a certain value. Why would they mark them up then?
So you
Oh,
make a
it's
profit.
They're gonna make a profit, okay? So they've got to increase it to make a profit. So technically, they've marked everything up to make a profit. So when they actually give you like 30% off,
They're still.
It's original
they're
price.
still right.
It's still
It
original
either
price.
goes back to the original price or it just goes like right above the original price. They're never actually selling anything to you for less than what they paid.
That's what
That's what cars.
But y'all think you're getting some kind of a deal when technically you're not.
Did you get a deal?
Huh?
Did you get a deal?
I mean, I got an extra discount because my brother sells cars. But no, not really. Okay, number 13, the percent decrease is 22%.
Did you get a smart car?
So we're going down. So how much are we paying? 78%.
78.
Okay, 78%. Written as a decimal is 0.78. Okay, they give us the new number. They want us to find the original, so we must divide.
Divided.
120.
120.
120. Last one in this section. Ralph Lauren is having a sale on some polo shirts. They're 17% off the original price. So what percent are we actually paying for? 83. Written as a decimal is 0.83. The polo shirts are now being sold for $29.05. What is the original price that they were sold for? So we divide. How much were the polo shirts to begin with before we gave you money off? $35? $35.
Probably going to hell store to get sales.
Okay. The last thing we need to talk about in this section is sometimes you'll see the price goes up and then they mark it down and then they mark it back up, or they'll even trick you and mark it up and then mark it up again and mark it up some more. Okay? So, how do we deal with the fact that it's being changed multiple different times? We find the decimal form for each percent of change. We multiply all of the decimal forms together, and then we determine the overall percentage by subtracting 1. So, if you look at example 1, it says it was originally marked up 10%. So that's 1.10. Okay, you add the 10, change it to a decimal. Then we mark it up again 20%, so 1.20. Finally, they mark it up 50% on top of that. So you would multiply all these together, you get 1.98. If you subtract 1, that leaves you with 0.98, which means you had a 98% increase. Okay? Same thing with example 2. They mark it down by 10%. Okay? Down by 40%, and then up by 80. Okay? Multiply them all together. Technically, you only got a 2.8% decrease because of that 80% increase at the end. So while you think you're getting a deal, when they marked it down and down, they screwed you at the end when they marked it back up.
How did it go from 97.2% to 2.8?
Because if you subtract 1, you get negative 0.028. So that means it's decreased, and you move it over 2.8%.
I don't even see how they get 2.8 by subtracting 1.
They're not gaining 2.8.
I don't see where the 2.8 came from.
Oh, because
You gotta make it to a
80
decimal.
from-
You gotta make it to a decimal first.
Oh, yeah, they're doing the decimal version.
It equals like negative 0.028.
They're taking the decimal version
I
of
get it, I
this
get it, I get it.
and
I got it.
subtracting one.
Yeah.
I can see where that's confusing, yes. Okay, so the original price of a new computer is marked up by 15%. What does that look like as a decimal? 1.15. Again, if you're struggling with this, 100 is being marked up, so we add 15, which is 115. Written as a decimal is 1.15. Then we're marking up 30%. So again, you would add 30. That gives you 130. Change it to a decimal, 1.30. Okay, so basically, you're changing this to a decimal and you're just sticking it onto the end of 1. Okay, so 20% comes out to be 1.20. What is the overall markup? Well, we need to multiply all these together. 1.15, 1.30, 1.20. 1.794. Okay, subtract 1. Now what do we get? What's left? 0.794, change to a percentage, 79.4% increase. Paying 79.4% over the original price. Okay, a car company initially marks up an original price by 25%. What does that look like as a decimal? 1.25. Then they mark it down by 30. 0.7. Mark it back up again by 10. 1.10. What do we get?
I be forgetting to put the decimal.
0.9625 minus 1. So this tells me we have decreased
3.75.
3.75%. So yeah, you think you're getting a big deal when they mark it down by 30%, but they've marked it up twice. So technically you're only getting 3.75% of the original price off, which is where they catch you. Let's go. Yeah, whole whopping like $2. Yay, you.
Hey, it's about
Question.
Jeez.
Okay. Exponential growth. So we talked about how an arithmetic series where I added or subtracted over and over and over again was a linear growth model. So it created a straight line. Geometric will create what we call exponential growth. So you remember all those lovely graphs in math class that went like this and curved up? That's what this is. Okay, so exponential growth is based on the idea of a constant growth rate. Which means that we multiply by the same number over and over again. Whether it be a whole number, a decimal, a fraction, we multiply by that same number over and over again. And that number is called your common ratio because we divide to get it. So, with the examples that you're given here, all I want you to do is calculate the common ratio. If you cannot see the pattern, the easiest way to do it is pick some number. So let's say we pick 192. You can take 192 and divide by the number that comes directly before it. Just like you could with arithmetic where you would subtract the two numbers. This time we divide. So if I divide 192 by 48,
4.
so 4 is your R value. That's telling you that you're multiplying by 4 over and over and over again.
This is geometry.
Yep.
G. Right, sweet.
You always multiply in geometry?
Yes.
Well,
1.5.
Okay, so B, 6 divided by 4, 1.5. Again, you can pick any number in the sequence you want except the first one, because there's nothing that comes before it. And any number you pick, you divide by the number that comes before. So here we do 2 divided by 6. 1/3. Okay, my only stipulation to you is, if in the sequence it's giving you numbers in fractions, keep your common ratio as a fraction. If it's giving it to you as decimals like you see in D, you can leave it as a decimal. Okay, so D, you can pick any one of these numbers. So 84.64, and we divide this time by 36.8 if we do that. 2.3.
We always have to do that.
What?
So we just like, since we know the answer, we just write down what it multiplies by. So we have to count
Like, are you asking, do I need to see 84.64 divided by?
Yeah.
No.
it. I could just do it 16 times.
But how are you just gonna come up with 2.3? Because that is not an easy one. Like, if you went back to part A and said, I can clearly see that that's multiplied by 4, yes. You are not gonna come up with 2.3 in your head, boy.
No, I'm not talking about that. I'm talking about like. Yeah.
Nah, this ain't work.
So like, yes, you can just look at this one and clearly say, yes, that's
I can do
multiplied
that.
by
I
4.
can do the work.
Are you gonna have to show work on your phone?
I don't know.
I don't care.
But your son says it'll work.
See, but
I'm gonna give this.
For something as simple as this though, Michael,
You put math in one.
okay, when you have to divide two fractions, please make sure that you put the fractions in parentheses. So you would need to do 22 divided by 21 all over. 2 divided by 3. Again, please put both sets of fractions.
11/7.
Okay? And because these are all in fractions, I want your answer as a fraction. So 11/7. If you do not know how to go back from a decimal to a fraction, you would hit math. Choice number 1 changes it back to a fraction. Okay, I want you to get the answers for the next 4. Take a minute and do the next 4.
Oh, yeah.
Huh?
Boy.
No one surprised.
That's good.
No, I didn't have no money.
Okay, so when you do something like E, you put it in parentheses, then hit the divide button. Okay. I got something like 4 billion. Y'all scared.
Because what will happen if you don't put these parentheses in there is it'll do 22 divided by 21,
Right.
divided by 2, divided by 3.
Right. I would.
They're not going to take the whole value and divide it by the whole value.
Boy.
Yeah, I got it.
I'm gonna take the best out of my life.
You said what? I swear to God.
You trying to kill me?
I said math 3.
Everybody should be working on these.
Oh, yeah.
You said the last
Right.
4?
Those of you that do not have calculators, I suggest we get up and get a calculator and do your own work and stop waiting.
Yes. How's your weekend?
You say how my week's been so far?
Is that what it's Sunday, Monday.
How was your weekend, Miss Smith?
I asked her how her week was first.
Why is it on the Tuesday? Why can't it be
It's
Friday?
I agree.
How was your day?
Why do we have early business?
Right, that's what I'm trying to figure
So,
out.
last year when they were making the calendar, the teachers suggested that we should have some more half days within the school year to give us some extra time to plan and stuff when you guys are not here.
That was great.
So they basically gave us one half day a month.
When is the one for this
one
one?
last month?
Lord.
Friday.
Lord.
Hey, I'll keep up with
He
that
said like
stuff.
10
Somebody
pounds
said
this
it.
big.
I said it yesterday, we just said it today.
Boss said.
Do you need some Q-tips? Would you like to clean out your ears?
No.
No.
Did we have one last month? Yeah.
No, I think we made it up once.
Yeah, because it was the 14th day, right?
That wasn't half.
No, that wasn't a half day, that was y'all leaving early because of prom.
Oh, yeah.
So that was not an actual official day.
Alright.
I don't think they gave us one last month because of spring break.
Alright.
I don't even
That was last month.
Oh, they gave us the day before,
Like it was a while ago.
spring break. It was like Thursday.
Yeah, they gave us the day before spring break. What do we get for R, for F? What is my constant rate? 3/5. What about G?
0.9.
0.9.
I changed it.
You could have, it doesn't matter. That one you could have left as a decimal because they're all decimals. H. 0.28.
13.7.
Last one's 13.7.
13.
And
Divided
13.7.
by
Is
one.
that 0.9 for Jason?
Yes.
Would you like to?
So much, it's just not able to be explained.
I'm glad you knew.
All right, so how do I know if I have growth or decay if I just give you an R value? No, your R value will never be negative if it is a decimal or a number bigger than 1. So if your R value comes out to be greater than 1, that means I have growth or it's increasing. So it can still be like 2.5. It's greater than 1, which means we have increased. If you have decreased, no, it will not be negative. You should never have an R value that is negative. However, it will be some number that is between 0 and 1. So 0.5, 1/3, 3/5. Okay. 0.00007. Okay. That all shows decay. So, as always, there are word problems. A mom offers to double her daughter's allowance every month for the rest of the year. The daughter currently has a $5 monthly allowance. So, what is my transition? Remember, that's how often is this happening?
Monthly.
How often? That means monthly. My transition rule. What is happening?
Everybody get
It goes up $5.
It
Times
doubles,
two.
Donnie.
Times 2. It's doubling. So that means 2 times the number that comes before. Okay? You would multiply by 2 every time. So what does the sequence look like then? Well, this is the initial value, so that's P sub 0. After the first month, she walks away with $10. The second month, no, 20.
Who said that?
Guys, you're sitting here thinking this is easy and a joke, and when it comes test time, you're going to look at this and go, I don't know how to do this. So please stop. So we're now at 20 in month 2. Month 3, that's going to take us to
40.
month 4.
80.
Month 5.
160.
Month 6.
320.
320. We're going to stop there for now. Okay. She's making bank right now. In the 6 months, she's going to get a $320 allowance.
That's crazy.
I want her life.
Right?
Can her mama adopt me?
Yeah.
Please take me. How much money will the daughter get in the last month of the year? So we've done 6 months. We need to do 6 more. So what comes after 320?
640.
640.
1280.
Yeah, 12.
1280.
2560.
2560. 3 more.
120.
10, 240,
I mean, let me do the math.
20, 48.
Right, bro.
Woo!
Right, let me get that.
At the end of the year,
So-
she's getting an allowance.
So wait a minute. Hold up. So,
Wait.
no, if she set up all her money for the whole year, she would get 20,000 a year.
No.
That's just one.
No, if she
check.
saved up all of her money, she'd have more than that.
Right. If she saved up all her money, she would have this, plus this, plus this, plus this, plus
Let's
this.
see how much she has.
Yeah, just tell me, Michael.
Okay. We will tomorrow get the formula on how to add up all this, just like you got with arithmetic. There is a formula to do this.
She
Okay.
has 40,900.
You said what? 40,900.
55.
Woo!
We need a job, bro.
Listen, she makes more than I do in a year.
Man, it's time to sell.
Woo! Listen, I just need her mama to adopt me, and I'm gonna quit my job and just get an allowance. I will scrub that house down every day with bleach if I have to.
That house will be stopped. I
Right.
swear to God.
You never see a crumb anywhere if you're gonna pay me that.
Walk around sleeping all day.
Okay. Example number 2. We've got $1,000 and we're depositing it into a retirement account. Something you're all gonna have to start to think about. You think because you're young that your retirement is not coming up. Guess what, honey? It's time to plan for that now.
Especially with Social Security
Right.
running out.
So we're depositing $1,000 into a retirement account that's going to pay 10% annual interest. So what's my transition period?
Yearly?
Yearly. Annual means yearly. What is my transition rule? We're going up by 10%. So what does that look like as a decimal?
Times
0.1
or 1.1.
1.1. Remember, it's going up. So it's going above 100 by 10%, which gives you 110, which means that's 1.10 as a decimal. So to get all your numbers, we would multiply by 1.10 each time. So what does my sequence look like? Well, I start with $1,000. After the first year, how much is in my account?
1,100.
1,100. After 2 years,
I got circuit.
now you need your calculator. 1,100 times 1.1 gives me what?
12.
1210.
And then I believe it comes out to be 1,330.
1330.
Okay. So look at D. Uh-oh. How much money is there in an account after 25
Can you
years?
put that as an expert or something?
We've only done 3. So we'll come back to this in a minute. Let me give you the lovely formula that goes along.
But you have to export it.
So the first thing you need to talk about before we get into the formula is the difference between a constant growth rate and the actual constant factor. So a constant growth rate would look something like this. 100% more than last year. Okay? This is a description that tells you what's happening. It's not actually the number that you're going to multiply by. The number you're going to multiply by is your constant factor. So if we are at 100% more than last year, okay, I showed you, everybody starts at 100. We're going 100% more than that. So that gives me 200. What is that written as a decimal? 2. So your constant growth or your constant factor is a 2. So you would multiply by 2 every time. Another way I can write this is 10% less than last year. Okay, again, the constant growth rate is a description, not the actual number you would multiply by. You would actually multiply by 100 minus the 10.
Smith,
Yes, ma'am.
can you send Jeremiah offer to change his mod?
Jeremiah has not come to class.
Okay, thank you.
So, written as a decimal is 0.9. So you would actually multiply by 0.9. That is your rate. Okay. So there is a difference between the two. Last chapter, we talked recursive formula, where you had to use the number to multiply and multiply and multiply and multiply. This time, I'm going to give you the explicit formula. Okay. I'm going to give you the shortcut that you would have to memorize if you wanted to use it. And I'm also going to give you the one that you're actually going to be given on your sheet. So the one you're going to be given on your sheet for your test is A sub n equals A sub 1 times R raised to the n minus 1. Okay. Remember, your A sub 1 is the second value. It's not your initial. For this, though, I can also use A sub n equals P sub 0 times R raised to the n. Both of these will give you the same exact answer. Okay, so you can take your initial value times your constant rate raised to whatever number you're trying to find. I personally do not care which one you use. But again, the only one you're going to be given on your formula sheet is this one. Okay, you're not going to be given that. So let's go backwards now. A sub n. Let's use the one that you would use, that you would be given on your test. So A sub 1 times R raised to the n minus 1. What value goes in here for A sub 1?
1,000.
Yep. 1,100 or 1,100 times. What's my constant growth rate? What are we multiplying by? 1.10. Raised to the. I'm trying to find 25 years, so you would plug in 25 minus 1. What'd you get?
11,000.
No.
$10,834.7.
This needs to be in parentheses. Do you see the parentheses on the board? You
9.7.
cannot skip that because what it's doing is it's raising it to the 25 and then taking whatever answer you get at that point and subtracting
I
them.
got 9.7.
Okay, it should come out to be $10,834.71.
I came out to the extra like
834, right?
Yes.
Okay, please plug this in so I can see what you're plugging in and what I need to tell you to fix. You must have just hit the wrong button.
Too hard in my
I don't mind.
You good? That's fine.
I mean, I got the answer. I'm pretty sure.
You didn't put 1.10, you put 110.
Oh.
You're missing the decimal. Okay, your biggest thing, please make sure if you use this one that you put that in parentheses. If you don't, it's going to multiply the first two, then raise it to the 25th power. It's going to give an answer, and then it's going to subtract 1. Okay, so you need to tell it to raise it to the 24th. Okay, so please be careful there. You would get the same answer if we would have done A sub n equals P0 times R raised to the n. So this one would have looked like 1,000 times 1.10 raised to the 25th. And it still would have come out with this answer. Okay, again, I don't care which formula you use, but this one's gonna be the one that they're gonna give you. So if you can't remember this one, this is gonna be the one you need to deal with. Do you wanna stick with the one you're gonna see?
Yeah, stay with that one, I like that one.
If you don't like that one and you like the other one, by all means, use it. Your answer should come out to be the same. So for this section, all we're doing is rewriting the formula. So 3, 6, 12, 24, 48. What is my R? Times 2. What is my A sub 1? 6. So this is A sub n equals 6 times 2 raised to the n minus 1. So now I can tell you, give me the 18th number in the sequence, and you would just plug in 18 for n and move on with your life. Okay? Super easy. I think geometric is so much easier than arithmetic. Part B. What is my A sub 1?
24.
What is my R? 1.2. Again, you can take 24 divided by 20. That gives you 1.2. So this is A sub n equals 24 times 1.2 raised to the n minus 1. And finally, C, we're looking at A sub 1, which is what? 300. And what is my R value? 0.75. Again, 300 divided by 400 would give you 0.75. So A sub n equals 300 times 0.75 raised to the n minus 1. Not too bad, right?
No, it's perfect. I like this.
Okay, here's another word problem.
Oh my God.
Oh my God. The number of reported cases of gamma virus has been dropping by 70% a year since 2004, where there were 1 million reported cases of the virus. What is my transition? How often is this happening? Yearly. What is my transition rule? AKA, what am I multiplying by? What is my R value? It's decreasing by 70. So what does that look like?
0.3.
0.3. We are going 70 less than 100, which gives me 30, written as a decimal, is 0.3. Okay, please. That is the hardest part, which is why I did the 100 plus and the 100 minus. Because everybody, as soon as they see dropping by 0.70 or dropping by 70, they just want to use 0.7. Do not do that. What is my initial population?
1 mil.
1 mil.
I put it as 1 n, so.
Okay. That'll be fine. When you stick it in the formula, though, you actually have to put all the zeros in.
Okay.
Okay, so part D says, what is the explicit formula? So I have R. I need A sub 1. What's A sub 1? How do I get it?
You times 0.3.
A million
Yeah.
times 0.3. So you need to solve for that A sub 1 first.
300,000.
300,000. So that means my formula is A sub n equals 300,000 times my R, which is 0.3 raised to the n minus 1. That's part D. Now, D or E wants to know how many cases will we expect in 2010? What goes in for n? 6. Why 6?
Because 10 minus 4 equals 6.
We started in 2004. It is now 2010, which means this needs to be 6 minus 1. If you can't remember to put that in parentheses, what is 6 minus 1?
5.
5, so you would just raise it to the 5th power. Okay, so if you have a hard time plugging it in with the parentheses, do your 6 minus 1 first. We get what? 729 cases.
729.
Case.
Get that much?
Are we in like a slow echo today?
You know,
I'm not the answer. You don't like the answer.
All right, we're not slow clapping.
What I got?
Hey, these 4 and we're finished for today.
Right.
Okay. So, number 1. Is there a reason we have to get up while I'm teaching? In the middle of it.
Yeah, fruit flies come to my desk.
Oh, good. We just won't bring food or drink in here anymore. That's fantastic.
On there, my.
Oh, we're right. Okay. I ate the fruit fly. All right. So, number 1 gives you the value for P sub 0 is 8. Your R value is 1.7. They want us to find P sub 16. So, what they don't give us is A sub 1. How do I get that?
8 times 1.7.
8 times 1.7, which gives me 13.6. So your formula is A sub n is 13.6 times 1.7 raised to the 16 minus 1, or just raised to the 15th power.
Jeez.
38,908.95.
Good. 38,928 and 95.
oh,
What is it?
We
Ooh,
don't
what place
know.
size that 5 landed?
Whatever you want.
Hundredths.
Oh.
Remember, when you go to the right of the decimal, it starts tenths, hundredths, thousandths. Okay. Number 2. What is my A sub 1?
100.
900. What is my R? 0.9. So, A sub n equals 900 times 0.9 raised to the, this time we're trying to find,
10 or 11 minus
okay,
1.
11 minus 1, or you can simply raise it to the 10th.
Let me do that calculation real quick. I think.
Oh, thanks. You're so sweet.
313.
Come on, this one. 300. What y'all say?
And listen, we were waiting on you. Come
Oh,
on.
they said that.
Come on.
313.
Come on, Louis. Come on, Louis.
Here we go.
I deleted it now.
Damn, Mike, stop doing
313.81.
Thanks.
.8105.961.
Okay. Number 3. We have an initial population of 20,000 with a 20% increase with each transition. What is the 5th generation? Okay, I need an R. 20% increase.
Ms. Smith,
Yes, ma'am.
can you send us your present to the office?
Sure.
0.1
Thank you.
or 1.2.
Yeah,
1.2. Again, it's 20% higher than 100. Written as a decimal. Not right now. I'm in the middle of teaching. Okay, again, it's 20% above 100, which is 120, which is 1.2 as a decimal. What is my A1 value?
24,000.
24,000. Okay, we had an initial of 20,000. We multiply that by 1.2, and that gives me 24,000. So, A sub n equals 24,000 times 1.2 raised to the 5 minus 1. I have to get through this first. Okay.
49,766.40.
You said 49,766.
Yeah. 410.
What am I doing right now?
Okay.
Oh my God.
Oh, we're not talking money. Why did I put money sign? We're not talking money.
You're supposed to read, that was nice.
Okay. All right. Last one, and we're finished. What is my R if I'm decreasing by 15%?
7.5.
7.85.
0.85. 100 minus 15 gives you 85. Written as a decimal is 0.85. Okay, it's decreasing, so we subtract from 100. What is A sub 1?
72,250.
Okay, so 85,000 times 0.85, you said was what now?
72,250.
So we've got A sub n equals 72,250 times 0.85 raised to the either 7 minus 1 or just raised to the 6th power.
Do I get cake?
Questions? Okay, we will finish 10.3 tomorrow. We'll do part 3 and part 4. Okay, the worksheet that you are getting right now, you are not going to be able to do all of it until we finish 10.3. But I'm giving